module, you will learn about the characteristics of sound waves. A complete sound wave can be considered as the repetition of the pattern of a single wave. That is, it consists of a number of compressions and rarefactions in succession. The length of a single wave is called its wavelength. In other words, wavelength is the distance between two consecutive compressions or two consecutive rarefactions. It is denoted by the Greek letter lambda. Since a compression and a rarefaction follow each other in succession, sound propagation is a periodic phenomenon. The interval between the generation of two successive compressions or two successive rarefactions is constant and is referred to as the time period of the wave. Time period is denoted by T and is measured in seconds. Frequency of sound is the number of waves produced in unit time. It is denoted by the letter N and is measured in hertz. The relationship between frequency and time period can be expressed as N is equal to 1 divided by T, where T is the time period. Thus, if the time period of a wave is 1/10 of a second, then we get 10 waves in 1 second. The frequency of this wave is 10 Hz. Listen to this scream and the cooing of a pigeon. Why is the effect of the two sounds on our ears so different? It is related to a concept called the pitch of sound. Pitch is the interpretation of the frequency of a sound by the brain. Commonly, pitch is taken as the frequency of sound. A scream is a high-pitched sound, since the frequency of a scream is high. Similarly, the cooing of a pigeon is a low-pitched sound. The shorter the wavelength, the higher the frequency, and the higher the pitch of the sound. Simply put, short waves sound high. Long waves sound low. Let's listen to some music. Is it a single instrument or two instruments playing? It is definitely two instruments. One sounds like a violin and the other could be a sitar. We could identify the difference in the instruments because of the type of sound we heard. Sound emitted by every instrument has a unique characteristic that distinguishes it from other sounds with the same pitch or loudness. This characteristic is the quality or the timbre of the sound. If we listen to either instrument playing the same tune separately, make out the difference in the quality of the two sounds. Sometimes, when you switch on your computer, you can hear a long beep indicating a boot-up error. Listening carefully, you make out that this beep is a uniform sound. This beep sound has a single frequency. Thus, the sound wave shows uniformity. This is an example of a tone. A tone is a sound wave of single frequency. A man on the left seems to be listening to some good music. A proper mixture of frequencies results in a pleasant sound or note, which we term as music or musical note. Thus, a note is a sound produced due to a blend of several frequencies. If a note is not pleasant to hear, it is simply called noise. Now, listen to these sounds. Can you hear me? Can you hear me? One sound was loud, and the other was very soft. What makes these sounds different? It is a characteristic called amplitude. The loudness of a sound depends on its amplitude. The amplitude of a sound wave is the maximum displacement of the vibrating particles from their mean position. It is represented by the letter A and depends on the force with which an object is vibrated. The greater the amplitude, the louder the sound heard, and the lesser the amplitude, the lower the audibility of the sound. Listen to these two sounds produced by the same drum. The second sound was louder than the first. This is because the amplitude of the sound produced the second time was higher. A loud sound can travel across a larger distance because it is associated with higher energy. Let's now look at the speed of sound. Speed is the ratio of distance to time. For a sound wave, the distance is its wavelength, lambda, and the time is the time corresponding to the wavelength, which is time period t. Therefore, the speed of a sound wave is the ratio of its wavelength to its time period. It is denoted by the alphabet V. The reciprocal of the time period of a sound wave is equal to its frequency. Therefore, the speed of a sound wave is the product of its frequency n and wavelength lambda. A tone is a sound wave of a single frequency. A note is a sound produced due to a blend of several frequencies. Amplitude A is the maximum displacement of the vibrating particles from their mean position. Speed is the ratio of distance to time. It is denoted by the letter V.